Okay, so we will be building an AND gate in Multisim. So to start, when you open Multisim, it should bring up a blank design with this blank grid here. If not, you can go to File and then New, or you can click in this toolbar up here, the New button on the far left here, and it'll bring up a menu that shows different kinds of designs. We just want a blank design, so click the blank design and then click Create, and that should open up a blank canvas like this. So this grid area is where we are going to be placing all of our components and building our circuit. So to start, we want a power supply. We want to use a standard 5-volt TTL power supply, and we'll be using that kind of power supply for basically all of our digital circuits that we will be building. To do that, we can go to this toolbar here. This toolbar in the upper left has buttons for all the different kinds of components we might want to place. For our supply, we want to actually place a source. We'll go to the Place Source button, which is the furthest left, and clicking that will open up this Select a Component window. We want to select the power sources family, and we're gonna go down to VCC. Looks like a little T. This is our standard TTL 5-volt power supply. So we can double click that or click OK, either way. And then it'll bring up this little silhouette showing you where it's going to be placed. So I'm just going to place it in the upper left here. And when we click to place it, it should place the part and then reopen this Select a Component screen. So now we want two switches because we want to control the two inputs to our AND gate. So we're actually going to go to this Group menu. If you close out of this window, we can reopen it by going to the Place Basic button on this toolbar, and that should open up the window again and automatically go to the basic group. If the window is still open from the last component that we placed, we just go to the group box and select the basic group. So now we want to select the switch family, and we want to select DIP switch 1, DIPSW1, and double click that or click OK. And the same kind of silhouette shows up. We want to place it, let's say, here. And we want two switches because we have two inputs to this AND gate that we want to control. So we'll go ahead and just select the same exact switch and place another one. Now we need our AND gate. And our AND gate's actually going to be in the, we're going to go to the group box again. It's going to be in the miscellaneous digital group. So we'll go ahead and select miscellaneous digital. We want to select the TIL family, and we're going to go to this AND gate here, AND 2. And we'll just go ahead and place the AND gate. And now we want some sort of output, some sort of feedback to know whether the output to this AND gate is on or off. So we can do that with a resistor and LED circuit. So first we need a resistor, which would be in the basic group. So go to our group box again, go to basic, and we're going to go to the resistor family. And we are going to see all these different resistor values. We want to use just a 100 ohm resistor. So we'll select the 100, double click that, place it right next to the AND gate output. And now we need an LED. The LED is actually going to be also in the basic group. It's going to be under the rated virtual family. And there are 4 different colors here of LEDs. LED blue rated, LED green rated, red, yellow. Doesn't matter what color, whatever you want. I'll just go ahead and pick a blue one. So we'll pick that component. And you'll notice it is oriented vertically, facing down. I want to put it in line with this AND gate output in the resistor. So I'm going to need to rotate this. To rotate it, you would, on your keyboard, hit Control R, and that will rotate it clockwise 90 degrees. We want the LED pointing right because the current's going to be going from the AND gate to the right. eventually to ground. So we're going to want to rotate this 2 more times so it faces the correct direction. And now we can place that. And we just need a ground to finish off this circuit. So ground would actually be in the sources group. So change the group to sources. It'll be under power sources. And this time we're going to select the digital ground, DGND. And we'll go ahead and place one of those. Now all of our components are placed and laid out. Now we just need to connect everything. So we can actually go to the close button on this window, close that out. And now we can just click on any node. We'll start with VCC. We'll click on this VCC supply node, and you'll see a line following your cursor around, showing you where the wire would be placed. And we just want to go over to the node on this switch here. And you'll see just under the cursor there's a little red dot that shows up, showing you that it's going to be connected to that node. So once we have that hovering over the switch node, we click it once, and now the line turns red, and it is now connected to VCC. So now we do the same with this switch. We want to connect this switch to VCC as well, so we're going to click the node on the other switch, go up to this VCC junction here, and click again, and now both switches are connected to VCC. So now we just connect this top switch by clicking the node there, clicking on the input to the AND gate, going to the other switch, clicking that node, and then clicking on the other input to the AND gate. And now connecting the output of the AND gate, we connect to the resistor, to connect the resistor to the LED, and then finally the LED to ground. And now we're done with our circuit. We've built it and are ready to test it. So to run the simulation, you can hit F5 on the keyboard, or you can click this little play button on the toolbar up here in the middle, the run button. So now I click that and the simulation is running. Now we don't see any color inside these arrows on the LED, but that's expected because we expect the LED to be off right now because both of the inputs to the AND gate are off. These switches are open, meaning the voltage on the inputs of this AND gate are both 0 volts right now. So yes, we would of course see no output here. To control our inputs, to flip them on and off, in this case they're both off right now. If we want to flip this first input on, we just hover our mouse over the lever of the switch, which once you hover over it, you'll see the lever thicken and become like a thick line instead of a thin line. Once you hover over it, you can click it and it'll close the switch. Again, our output is off right now because only one of the inputs is now connected to 5 volts. The other input is still 0 volts, as expected. So then when I close this other switch, we'll see the LED turns on. It turns blue because I selected the blue LED. And we see that the output is on, so we know that the output of the AND gate is 5 volts, or a 1, a digital 1. And this is expected because both of the inputs in the AND gate are now 5 volts, or a 1. And then if I click one of those switches again to open it up, now I'm setting the input of the AND gate to 0, which then turns off the output and turns off our LED. Now finally, if we want to measure the raw voltage at the output of this AND gate, first of all we have to stop the simulation because we cannot make any changes to the circuit. You'll notice that when the simulation is running, these toolbars are all grayed out. The toolbar on the right, on the far right here, is grayed out. So we won't be able to do anything with the circuit unless the simulation is stopped. So we need to hit the stop button, and that enables all of our components and everything again. We're going to go to this far right, this vertical toolbar. Now this vertical toolbar has all of the various measurement devices. We have, Bode plotter and oscilloscopes and function generators. What we want to select for this case because we just want to measure the raw DC voltage, we're going to go to this multimeter. It's the first button at the very top of this toolbar. We're going to click that button once, and it's going to bring up our silhouette again. And we'll just place this wherever. And then we'll connect it, the positive end to our AND gate output, and the negative end to our ground for the reference voltage. And now we can run the simulation again. This time, since we have the multimeter connected now, we can double click the multimeter, and that'll bring up this little window here that shows the voltage. Right now it's 0 volts because the output of the AND gate is off. If I flip one switch on, still off, still 0 volts. But now if I flip both switches on, our LED lights up, and then we read 5 volts on the multimeter. And then if we flip one switch off, the multimeter goes back to 0 volts. So for the lab document that's available on Ivy Learn, in the module section of Ivy Learn for Chapter 1, there is a first day lab Word document that looks something like this. You can ignore steps 1 through 6 because we did all of the circuit building in Multisim. So step 7 is what's important. We have this table here with inputs A and B. These are the inputs to an AND gate, and Y would be the output. So for our circuit, we can consider the inputs to be these two switches. So we can make this top switch A and this bottom switch B, for example. So those would be our two inputs. And when the switch is open, that represents an off, because the input to the AND gate would then be 0 volts. So it would be a 0 on the input here. And then a closed switch would be a 1. So that table, when it says A is 0, B is 0, it's asking what the output would be and what the voltage at the output would be. So for the Y output, we are considering the inputs 0, 0, meaning both switches must be off, meaning both of them have to be open. And the condition, so those are the conditions. We want to know what the output is. Well, the output is a 0 because there's nothing on our LED. Our LED is not lit up, so the output would be 0. So we would fill in a 0 for this Y section, for this first line, or this first row of the table. And then for the voltage, in the voltage box, we just go to our simulation, go to our multimeter, and we read that it is 0 volts. So we would write down 0 volts in the table here. And then for the rest of these conditions, we are basically just flipping switches and getting the same output, a 0 or a 1, and then the voltage read by the multimeter. So for the second condition, with A0 and B1, if we're calling the top switch A needs to be 0, which it is right now, it's open. B needs to be a 1 though, so we need to close that switch to turn it on, the input to the AND gate. And we would just record our results there. In this case, it would be a 0 for Y because there is no output, and it's measuring 0 volts as well. So we would fill in a 0 for Y and 0 volts for the voltage. And repeat these steps, just flipping switches on and off according to what the inputs are for each of these rows on this table, and fill in the Y output, a 0 or a 1, and the voltage that's read by the multimeter. And that is how we build a simple AND gate circuit in Multisim.